Question number 41 is still on coordinate geometry. And here we have two different equations. And we are asked to find the value of k if the two lines are perpendicular to each other. The first line is 3y equal to 4x minus 1, and the second line is ky equal to x plus 3. So from each equation, we are going to make y the subject of the formula. From equation 1, I have y equal to 4 over 3 x minus 1 over 3. From equation 2, I have y equal to 1 over kx plus 3 over k. Since the two lines are perpendicular, the gradient of the first is 4 over 3. The gradient of the second is 1 over 4. So the product of the gradient must be equal to 1 minus 1 since they are perpendicular. 4 over 3 times 1 over k is equal to minus 1. From here we have 4 equal to minus 3k. And we now have k is equal to 4 over minus 3. So the correct option here is A, which is minus 4 over 3, as you can see. We are moving to a new topic, and this new topic is sequences and series. Now, when you are talking about a sequence, you are referring to an arrangement of numbers in either increasing or decreasing order of magnitude. However, there could be a situation whereby the numbers are neither arranged in descending or ascending order, yet it will form a particular pattern of arrangement. This, as the case may be, we are going to consider questions on arithmetic of progression, simply called AP, and the geometric progression, which is also called GP. And another name for arithmetic progression is called the linear sequence, whereas another name for geometric progression is exponential sequence. It is compactly given as GP. Now considering the following questions. Question number 42. The nth term of a sequence 3, 9, 2, 7 is dash. The nth term of the sequence, as you can see displayed on the screen, 3, 9, 27, 81 is dash. You want to find the nth term of this sequence. All you just have to do is to write out the sequence as given 3, 9, 27, 81. The general term of, or the nth term of a geometric progression is given as AR raised to power n minus 1. And if you look at this one, you will see that it is not an arithmetic progression because it doesn't have common difference. The successive terms doesn't have common difference, and as such, you test for the common ratio. And how do you obtain the common ratio? Generally, the common ratio R is Tn over Tn minus 1. In this case, if you want to test using the first two terms, it's going to be T2 over T2 minus 1. Therefore, it's going to be T2 over T1. We proceed. We now have our R equal to T2 here over T1, or T3 over T2, or T4 over T3, which is equal to R, as you can see in both cases. So here now, I'm going to have my R equal to 9 over 3, which is equal to 3, meaning that the common ratio is 3 and the first term is 3. Since I want to obtain the nth term, the relevance of the nth term is that it will enable me to get any terms in the sequence, because the nth term is always expressed in terms of n. We proceed to write the nth term of this as 3, by 3. Because A is 3, R is 3, n raised to power 3 by 3, n minus 1. That is 3 times 3 raised to power n minus 1. Therefore, the nth term of this sequence is option B. Option A seems to be a correct answer too, but you will discover that that particular n is not a power. It is also a base. So the correct option there is option B. Question number 43. It is given that if the second term of a GP, if the second term of a GP is 8 over 9, and the sixth term is 4 whole number 1 over 2, we are required to find the common ratio. We set an equation. T2 is equal to 8 over 9, and T6 is equal to 4 whole number 1 over 2. So this one will give us AR equal to 8 over 9 and A raised to power 5. AR raised to power 5 is equal to 9 over 2. Now, if this is equation 1 and this one is equation 2, we want to obtain the value of R. We obtain the ratio of 2 to 1 in this order. And as such, it's going to give us AR raised to power 5 over AR equal to 9 over 2 divided by 8 over 9, in which we are going to have this one to take care of this, and this one will be left with 4 is equal to 9 over 2 times 9 over 8. So R raised to power 4 is equal to 1681. So we look at this one. Since R raised to power 2, since R raised to power 4 is equal to 81 over 16, we put it as 3 over 2 raised to power 4. Therefore, since they have the same power, the bases must also be equal. So we are now saying that R is equal to 3 over 2. Question number 45 is still on sequences and series. We are required to find the common difference of this arithmetic progression whose fourth term is 24 and the 11th term is 52. We are given two terms here. One is the 11th term and its value is 52. The second is the fourth term and its value is 24. So looking at it, we want to find the common difference. The fourth term is given compactly as T4, fourth term is T4, and it is given to be 24 according to the statement of the problem. And 11th term is given as T11 and the value is 52. Do not forget that the nth term of an AP is given as A plus N minus 1 into D. So looking at this one, we have T4 to be A plus 3D equal to 24. Then we have T11 as A plus 10D equal to 52. If you look at this, how do I arrive at this particular A plus 3D and A plus 10D? You will see in the general nth term that the coefficient of D is 1 less than the term under consideration. Here we are considering the nth term, and the coefficient of D is n minus 1, whereas this A remains constant. That is why if we are considering T4, our A remains constant, and the coefficient of D will be 1 less than 4, which is 3. The same thing also goes for the 11th term. Now we have two equations. These equations are A plus 3D equal to 24 and A plus 10D is equal to 52. We want to obtain the value of D. How do we obtain the value of D? We can subtract equation 1 from equation 2. If I'm subtracting equation 1 from equation 2, it means this A will go, and if you subtract 3D from 10D, what you have is 7D. If you subtract 24 from 52, what you have is 28. Therefore, D is equal to 28 over 7, and 28 over 7 is equal to 4. The common difference of this particular sequence is 4, and that is option A, as you can see. The next question is question number 46. This question is given in terms of a word problem, and it is given that the 6th term of an AP is half of its 12th term. This is the relationship that connects the two. The 6th term is still 6, and is half of the 12th term, which is still 12. This is A plus 5D equal to half into A plus 11D. This one will give us A plus 5D is equal to half, is equal to half into A plus 11D. That step is repeated. You cross multiply, you have 2 into A plus 5D is equal to A plus 11D. This one will give us 2A plus 10D is equal to A plus 11D. This one will give us 2A minus A equal to 11D minus 10D. Then you have A equal to D, meaning that the first term is equal to the common difference. And the correct option there is option C. This one, question number 47, given that the first and the fourth term of a GP are 6 and 162 respectively, we are required to find the sum of the first 3 terms of the progression. Now, in this question, the first term, A, is equal to 6, and the fourth term, AR raised to power 3 is equal to 162. We are required to find the sum of the first 3 terms of the progression. It's a GP, and these particular equations will enable us to find the value of R. If R is less than 1, we know what to use. If R is greater than 1, we know what to use. Now, here I am going to have the ratio of equation 2 to 1 in this form, which is AR cubed over A equal to 162 over 6. This will cancel this. And this implies that R cubed equal to 27, because 162 over 6 is 27. Then, which now implies that R is equal to cube root of 27 and R is equal to 3. Since R is greater than 1, we proceed to apply Sn equal to A into Rn minus 1 over R minus 1. R is greater than 1 in this case. Therefore, S3 is equal to, the first term is 6, into this one. R is 3 raised to power 3 minus 1 over 3 minus 1, which will give us here 2. This is 3 minus 1, which is 2. 2 goes in 6. That is 3 terms. We now have it as 3 into 27 minus 1, which is equal to 3 into 26. 3 times 26, 3 times 26, 26 times 3, this is 8, this is 78. It means the correct option there is 78, and hence the sum of the first 3 terms. We are moving to the next question. The next question is question number 48. This question number 48. The next question is question number 48, and it is still on sequences and series. The question is, how many terms of this series, 3, minus 6, 12, minus 24, are needed to make a sum of 1 plus 2 raised to power 8. Now we need to test, we need to write out the sequence as 3, minus 6, 12, minus 24. The common ratio here is minus 6 over 3 or 12 over minus 6 or minus 24 over 12, which is equal to minus 2. Since the common ratio is less than 1, we recall that Sn is equal to 1 is equal to A into 1 minus R raised to power n over 1 minus R. From here, we have Sn equal to, the value of A is 3. Is 3 into 1 minus 2 raised to power n. So this one, the total is already given as 1 plus, this is over 1 minus 2, which is equal to Sn equal to 1 plus 2 raised to power n. From here, the total is given to be 1 plus 2 raised to power 8 equal to 1 plus 2 raised to power n. Looking at this one, 2 raised to power 8 is equal to 2 raised to power n. Since they have the same base, then we equate the power as n equal to 8. It implies that a total of 8 terms are needed in order to get the sum of 1 plus 2 raised to power 8. And according to the question, the correct answer there is 8, and it is D. Question number 49. We are required to find the sum to infinity of the series. The series is given to be 3 plus 2 plus 4 over 3, and it continues that way. Since it is about sum to infinity, we write out our R. Our R is 2 over 3. Obviously, 2 over 3 is less than 1. And as a result, we recall that Sn is equal to A over 1 minus R. The first term here is 3, and we substitute as 3. The common ratio is 2 over 3. So we write 1 minus 2 over 3. Since we have this, we have S to infinity equal to 3 over 2 over 3. No, sorry, 1 over 3. Since I'm subtracting 2 over 3 from 1, I'm going to have S to infinity is equal to 3 over 1 over 3, which will give me 3 divided by 1 over 3, which is equal to 3 times 3 over 1, which is equal to 9. Therefore, the sum to infinity of this series is 9. And as you can see, the correct option there is D. Question number 50. The question number 50 here is also talking about sequences and series. But this time around, it's not talking about GP, but AP. The fourth term of an AP is 13, while the 10th term is 31. We are required to find the 21st term. The fourth term is 13. Conventionally, let us put the fourth term as T4, and it is given to be 13. The 10th term is T10, and it is given to be 31. So we are required to find the 21st term. As it is here, this fourth term is A plus 3D, which is equal to 13, and the 10th term is A plus 9D, which is equal to 31. What we just have to do here is, we have two equations. Then we solve simultaneously. How do we solve simultaneously? We subtract equation 1 from equation 2. This one we go, 3 from 9 will give us 6D. And if you subtract 13 from 31, what you have is 18. Therefore, the common difference is 3. If the common difference is 3, we substitute this value into any of the equations. Substituting D into any of the equations, you would see that A plus 3 into 3 equal to 13. And as such, A plus 9 equal to 13. We have A equal to 13 minus 9. 13 minus 9 is equal to 4. So A is equal to 4. Since A is 4 and D is 3, we recall that the 21st term, T21, is equal to A plus 21, A plus 20D. This one, we have T21 equal to 4 plus 20 into 3, which is equal to 4 plus 63. 4 plus 60, which is equal to 64. So if you look at this question, you will see that 64 is in the option, and the correct option in this case is 64. We are moving